Hello, I'm Neal Spackman. I'm here at Masdar City where we have a 2-hectare demonstration of our regenerative seawater agriculture system. So here you have the aquaculture component of the system. You can see these are tilapia ponds. This is a research system, but we've got 6 tilapia ponds, and the wastewater off of this system is used to irrigate the rest of it. And then here you have Salicornia fields, and these were planted 3 weeks ago. This particular field is flood irrigated with wastewater coming from the tilapia ponds. That wastewater is high in nitrogen and phosphorus. From an aquaculture perspective, that wastewater is a problem, because either you dump it in the ocean and you pollute the ocean, or you pay a lot of money to filter it. In this system, we turn that pollution problem into a fertilizer solution. But these, in a month, they'll be 8 to 10 centimeters. Okay, and so Salicornia is a very useful crop. In this context, in Abu Dhabi, the most important use is for animal fodder, because 100% of their fodder is imported for their dairy and meat industries, and we can grow that domestically, high quality fodder crop without using any fresh water. Here you have the mangrove component of the system, so we're downhill from the Salicornia fields. But it's important to bear in mind that this was bare sand 6 years ago. Now, one critical aspect of this is the circular economy piece. So I'm gonna harvest some leaves. Mangrove leaves are really important to the viability of our system, and they are the part that makes this whole thing kind of wondrous, aside from the fact that we're using seawater to grow food. Chunked up mangrove leaves that I've torn up in my hand, and you will see that when we throw it in, that the fish will come and eat the mangrove leaves. And so this is an illustration of where circular economy and agroecological systems can outperform other conventional commercial systems. For a typical aquaculture farm, the wastewater is a huge source of costs, right? Either an aquaculture farm dumps its wastewater in the ocean, which causes dead zones and algae blooms, and eventually pollutes their own water system, because they pump their own water from the ocean and they're polluting that water, and that increases the prevalence of white spot disease. It increases nitrogen and phosphorus density, and that creates all sorts of problems. So that's a massive cost center where they're dumping it into the ocean. Or, as in a recirculating aquaculture system, they treat the water mechanically, right? They have expensive filters, but either way, the wastewater for our competitors is a cost center. So what we do that's different is our wastewater becomes fertilizer for additional revenue streams. We make money off of our wastewater, and we create products and inputs to our aquacultures that improve performance. So for a shrimp system, mangrove leaves have been shown to drastically improve health, to improve color and texture, and to reduce the amount of feed needed to grow your shrimp crop to market weight. And that translates to a massive cost savings in terms of operations, in terms of better health, and in terms of better product quality. So we can do this on any desert coastline and make desert or degraded coastal land productive using seawater. But it also creates massive advantages from the aquaculture perspective and from the agriculture perspective. And this system is, our proof that we can do it in the middle of Masdar City on bare desert land that used to be bare sand. This is a proof that illustrates the advantages of our system.